And now we install Klipper firmware. Most of the time in the basement, we run Marlin firmware on our printer's main board. Essentially, Marlin is what allows us to take G-code commands and turn it into printing movement. Marlin and Klipper, at the end of the day, pretty much achieve the same goal, although Klipper does it quite a bit differently. Klipper takes your printer's main board and pairs it with a Raspberry Pi running Octoprint, so that you can offload that processing to the Pi to that much faster processor. So you can process data faster, and the ultimate goal being printing faster. Now, Klipper is quite a bit different to get set up. Essentially, you're flashing some firmware to your printer's main board, and then you're doing the configuration in Linux on the Pi. So today, I'm going to show you how to get everything set up on Log. Log is running an ATmega and RAMPS combo mainboard. You're going to need a Raspberry Pi with Octoprint installed. As always with the Raspberry Pi, please be sure you have the correct adapter for the Pi so you have enough power. If you need to know how to get Octoprint installed, you can check out this video up here. But with all that said, let's head over to the computer and get everything configured. Now before we get started with the install of Klipper, I highly recommend you connect up to your printer with some sort of terminal interface. I use Pronterface. We'll connect up and run an M503 command. If you're running Marlin, this is going to give you a lot of the settings that you'll need when you're setting up Klipper. So I'm just going to copy all these values and paste them in a Word doc so I can use them as I go through the config. Now on to the Klipper install. So we're going to start by heading out to the Klipper GitHub. We're going to take a look at the quick install guide that Kevin has provided. These are essentially all the steps that we're going to take to get everything installed. So you can come in and copy and paste the commands that I use from here. Link in the description to everything I use today. So we do have a brand new Octoprint instance installed on that Raspberry Pi. So the first thing we're going to do is use Putty to get into it SSH. We'll log into Octoprint. Username Pi, password Raspberry. So back to our guide, first thing we need to clone Klipper from GitHub. So we'll use this command here. So now we've pulled Klipper down from GitHub. Now we're going to run the install octopi shell script to install it. Enter your sudo password, default is Raspberry. This part takes a few minutes. That part took about 10 minutes, now we can change directory into home/Klipper. And we can run a make on menu config to compile it. Here in this menu is where you can select on what processor and board you're using. I'm going to go with defaults because I'm using an AVR ATmega board. I'm using the 2560 processor. It is 16 megahertz, and UNART 0 is my serial port, and I'm going to leave it at 250,000 baud rate. So for me, I can just hit save. But you might want to select something else if you're using a different board. And I'm just going to use .config for my configuration, so I'm going to hit OK. Configuration has been written. Now we can hit enter to exit. And then from the main screen, we just hit exit again. And after the menu config is complete, we can just type make. The compile is complete. Now the next thing you want to do is plug in your printer into your Raspberry Pi. And I'll show you why. So the printer's plugged in and turned on. Now let's do an ls/dev. Sometimes you're going to have TTY USB values. Sometimes you're going to have ACM values. This printer is an ACM 0, this value right here. And that's important for our next couple of commands. So back to the install doc, we're going to stop the Klipper service, and we're going to use this command to flash our firmware to our printer's mainboard. Again, sometimes this won't always be ACM 0. It could be a USB value. So make sure you check that ls/dev. So we'll go ahead and flash. Now it's uploading to the mainboard, and now we can start the Klipper service with this generic configuration just to make sure everything went well. No errors, so we're looking good so far. Now we need to configure Octoprint via the GUI to use Klipper. So we'll go to our Octoprint instance, and after we've logged in, we'll go to Settings. In the first screen, Serial Connection, under Additional Serial Ports, we need to add a temp port. So /TMP/printer. And we'll go ahead and hit Save. So back into Settings again, Serial Connection, click on the Behavior tab up here on top. You want to make sure the radio button that says cancel any outgoing prints but stay connected to the printer is checked. We can hit save again. Now here for the main page, we'll go ahead and hit refresh, F5. And on the serial port, we'll set it to temp/printer, the one we just created. Our baud rate was 250,000. We just set that in the config file. We can go ahead and save, auto connect, and hit connect. Now Octoprint is connected to Klipper. You can see it from the terminal right here. And from the terminal, you can just do a status, and it's giving you an error because our printer config file isn't configured yet. but we do know that Klipper is communicating with the Raspberry Pi and the mainboard. So here's where all the work gets done. First thing we're going to do is copy the example config over to a printer.config file and start from scratch. So we'll run this command, and then we can edit that printer config file. But before we do that, I want to show you that there are some default configs that you can use for your printer. So if you do a cd config, and then you do an ls, these are all the printers that are already configured for Klipper. So if you have one of these printers and you just want to use one of these configs, go ahead and use this as your printer.cfg. But I'm going to walk you through setting it up step by step from scratch, so you know what's going on. So back to our install. We'll do a nano home directory printer.cfg. And we're just going to step through this section by section and get this printer configured. Now at the top of this config file there's some good information, but we start with configuring stepper drivers. But this information right here is very handy to have. So if you're configuring an Arduino-based board like we are, you're going to use a prefix of AR and then the Arduino pin number. And what that pin number is, it's the same pinout as a RAMPS. So just for example, this end stop pin right here is listed as AR3. If you take a look at a RAMPS pinout, your X minimum end stop pin is right here, and it's the D3 pin. So it's pretty much one for one on Arduino-based boards. Other than having that AR prefix, there's a couple of other things you need to worry about. And those are listed right here. So if the pin needs to be inverted, you need to put an exclamation point in front of it. So if the end stop's going the wrong direction or the motor's spinning the wrong direction, you can invert it with this exclamation mark. You'll see that as we go. And then also you have this caret that you can add to the pin. The caret enables the onboard pull-up resistor, and you do need that for certain types of switches and encoders. So you'll see that as we go through. But that's what those two things mean. So we'll start with stepper X here at the top. Since we selected the 2560 mainboard, this example configuration is going to be mostly correct for what we need. We have to add a few things and change a few things, but for example, step pin 54, that is the correct step pin for stepper X. Now step distance is one of the things in Klipper that's going to take some getting used to. This is the value of the distance in millimeters that each step causes the printer to move. In Marlin, it's the other way around. We would list how many steps it takes to move 1 millimeter. This is pretty easy to figure out if you already know your Marlin values, steps per millimeter, but you can also use the Prusa calculator to figure this out. So here, for example, I'm using a 1.8 degree motor, 200 steps per revolution, a 2 millimeter pitched belt, I'm using a 16 tooth pulley, and 16 times microstepping. So that calculation comes out to 100 steps per millimeter. So you can just reverse engineer that number. So we're looking for the distance in millimeters that each step causes the printer to move. So really all you need to do is divide 1 by this number that you got out of the calc. So 1 divided by 100. That gives us 0.01 millimeters per step. And again, if you've saved your 503 information, all of those values are right here. So for the rest of this config file, I'll just be pulling on the values I already have, so I don't have to go figure them out again. So back to the config, we'll just use the value of 0.01. The next thing I needed to change was how the X end stop gets triggered. By default, you have a pull-up resistor, which I kept, but I also needed the logic inverted. So I just add an exclamation point right there. Then we come down to max position for X, minus 250. And then homing speed, 5 is really slow, so I'm going to set mine to 40. And now we'll head down to the Y stepper. It's pretty much all the same information without the explanation, so you can treat it just like you did the X. Again, step distance is 0.01. My end stop needs to be inverted and a pull-up resistor. My position max is 210. And I also want to set the homing speed to 40, so you can just add that right in here. Homing underscore speed, colon, 40. Now onto the Z motor. First thing we need to change is the step distance. I'm using TR 8x2 lead screws on this printer. So to move 1 millimeter, it takes 1600 steps. So that calculates out to 000625. I'm also going to comment out the end stop pin value for Z because we use a probe. You'll see that down below here in a moment. Position end stop can also be commented out because we're using a probe. And we need to add an end stop pin for a virtual end stop. That's just how Klipper treats the probe. I'll show you about that in the probe section. But we're just going to do end stop underscore pin, colon, probe, colon, Z underscore virtual underscore end stop. My Z max position is around 200, and I'm going to add a position minimum. So position underscore min, colon, and I'm going to make it -1. I'm adding this because we're going to do auto bed leveling. Auto bed leveling can sometimes sense a value that's less than 0 because it's trying to take a level map of the bed, and things might be lower or higher for some reason. If Klipper senses that it's going to a negative movement during its first print line, it's going to throw an error and fail the print. So you need to tell it that it's okay for it to go a certain amount past 0 in the negative. That's what this value is going to do. So on to the extruder. So it's probably a good idea to go ahead and calibrate your extruder before you do this, but I'm just going to pull my value out of my 503 command, and it's 135. So my step distance turns out to be 7407. My nozzle diameter is a 0.4. My filament diameter is 1.75. And then we can continue on down the file until we get to max and min temp. PID calibration can be done later. I'm just going to go with the default for this tutorial. Min temp should be 0. I'm going to set max temp to around 250 because I have a Teflon lined hot end. Now by default, this is using 100K thermistors. That's going to work for pretty much every situation, but you might want to change that up to something that's a little closer to what you actually use. But for this test, it works just fine. Max bed temp, I'm going to leave that at 110. The fan pins by default for ramps should be set correctly. No issues there. You do need to pay close attention to this serial setting. So whatever you use to flash that ACM0, whatever was in your ls dev command, it needs to be the same here or you're going to have some problems. By default, it is ACM0 and that's what I am using. So I'll leave it. Also, the default baud rate is 250,000. That's what I am using. And if there is a default value, if it says it right here, this is the default value, you don't need to uncomment it. It's just going to be baked in. So we should be good here with the default. We don't have to change anything. And then we come down to max Z velocity. This is something I had an issue with during the install. Klipper was spinning my Z-rods way too fast. I have a really fine threaded lead screw that I use on this printer, and if you spin them too fast, it's going to stall out the motor. So I changed max Z velocity from 25 to 5, and this seemed to clear up that issue. It does turn them quite a bit slower, but that's about where my printer's happy with it. So just be aware of that. And then we scroll on down, and you'll notice we're at the bottom of the file. We didn't set up mesh bed leveling, probing, LCD screens, anything like that. But it does give you this comment that you can find extra stuff in the examples extra.cfg, and that's exactly what we're going to do. So we'll Control X, hit Y, and enter to save, and we'll change directory over to config, and this is the example extras config that we want to take a look at. So let's just cat that file so that we can scroll back and take a look while we're editing our other file. That's good for now. Let's jump back a directory and go back into our config file. We'll go all the way to the bottom, and then we can scroll up and take a look at that extra config. So we'll just start at the top of that. If you can't scroll back this far in your terminal window, you can go up to settings and add a few more lines if you like. So in the example extra config, the first thing you see is Z-probe. So we're just going to take this whole section with us, right there. And if you hit your up arrow, that'll take you back to your nano where you're editing this file. You can right click just to paste it in. So these are all the options you need to use a Z-probe instead of a Z-in-stop. And there's a few things we need to change. So for our probe, we use the minimum in-stop pin. So we're going to remove this comment, and we're going to change this to 18. Our probe also requires a pull-up resistor, so we're going to add the caret. And the logic is flip-flopped, so we're going to add an exclamation point. And then we're going to remove the comment for Z offset. Now I'm taking what my current Z offset is in Marlin, and that seemed to work correctly, and that is a 0.9. Now you're probably going to have to play with this after a first couple of prints. So run a print, see how high it is, and then maybe come back in here and change it if you need to. But I'm sticking with the Marlin that I have right now, so that'll work. Everything else should stay default for probe. Now let's scroll back up and take a look at a few more options. So again, we're looking at the example extras.cfg. We already did the probe. There's options for BL touch. There's options for bed tilt. And then we come down to mesh bed leveling is what we want. Now note, you can't use like skew correction, the tilt feature, with mesh bed leveling. You have to pick one or the other. We're going to go with mesh bed leveling. We're going to select this whole area, right down to here. And then up arrow to get back to our nano file. We'll leave a space, and then right click to paste. Let's scroll back up to the top of that. I forgot to show you in the probing section about that virtual probe. Let me scroll back just a second. So in the information for probing, this is what tells you how to set up that probe Z virtual in-stop that we did before. We've already done this, but I just wanted to show you where the information was in case you wanted to know more about it. So back to mesh bed leveling. So here's some information on it. They typically want you to home in the center of your bed, but with this Mark 42 bed, we actually need to hit some certain spots, so we have to do a few more things differently. So speed of 50 is fine, horizontal movement of 5 is fine, samples 1 is fine, you can do multiple touches if you'd like. Min point does need to be set, there's no default for that. And if there's no default, it's going to tell you this parameter must be provided. Our first spot, we actually hit 0, 0. That's 0x, 0y. It starts in the very corner of the bed. And our max probe point, this is what took a little bit of playing around with. And it's only because I hit very specific spots, 9 points on the bed to probe. I have to be on target. And for the Mark 42 bed, what I found worked was 200 for the X, and do a comma, and then 195 for the Y. That gets me dead on each spot when I probe. Probe count by default is 3, that gives you a 9 square, that's good. Fade start, fade end, most of the stuff we're just going to leave it default, and that should get all the mesh bed leveling stuff set up. So we'll scroll back up and take another look at that example file. Now we need to set up an LCD screen of some kind. So we've got bed leveling, let's keep scrolling. There's stuff for multiple Z stepper tilt adjustment, moving gantry leveling, multiple extruders. There's some heating temperature verification, idle timeout settings for your motors. So as we go through the file before we get to LCD, this is definitely something I wanted to add. And this is so you can assign a pin to kick on your hot end fan when the extruder's on. And when it goes off and it comes down to a certain temperature, the fan will go off. I really like this feature and I want to add it. So let's copy this block of code. Up arrow to go back to our file. We'll just paste it in right here. So my hot end fan is controlled by pin 6. So we'll just put that there, AR6. Max power can stay default, it's going to be maximum anyway. Shutdown speed doesn't matter to us. Cycle time, hardware PWM, kickstart time doesn't matter to us. By default, it's going to be controlled by the extruder's thermistor, and that's exactly what we want. And the hot end fan is going to kick on the second the extruder starts, and then it's going to kick off when it gets down under 50 degrees Celsius. And that's default, and that's just fine with me. Fan speed is expressed at 1, and that's full power. So you have 0 as off, and 1 is full power, and that's fine as well. So let's scroll back up to the extra configs and grab some more. So we left off a heated fan. There's another temperature triggered fan setting right here that you can use for enclosures or your hot end if you'd like. Definitions to use additional microcontrollers. We don't need to check that out for now. Servos if you like, if you use one for a bed probe or something like that. You can configure statistic output to gain a little more information. Runtime configurable output pins. Here's where you can configure TMC2130 stepper drivers. I'm not going to configure that today. I'm just using A4988s. You don't need to do anything with those, but the feature is here if you want to use it. Settings for 2208s, settings for 2660s. Here's example G-code commands that you can use to override homing if you need to do something a little bit different when your printer homes. I'll show you a little bit more about this here in a second. Virtual SD card, by default you're going to use Octoprint since you're already hooked up to Octoprint with this Klipper install anyway. But you can use a virtual SD card, but it's going to let you use a file on your Octoprint server to do that. So as far as I know, there really isn't any onboard SD card support. You're already tied to Octoprint. And then we come down to the LCD section where we need to configure LCD screen. We're using a 2004 LCD to screen, and the chip on those is an HD 44780. So we're just going to copy this whole LCD block, although we don't need most of it. We'll up arrow back to our config file, leave a space, and we'll paste it in. So we'll uncomment display because we're going to use one. We'll uncomment LCD type, and we're going to put in HD 44780. Now you'll notice none of the pins that support the LCD screen are set. They don't even have default values. And I found the easiest way to configure this is just to go take a look at Marlin. So if you pop open Marlin, it doesn't even have to be configured for your printer. Any Marlin config will do. Go to the pull down over here and go down to pins_ramps.h. And if you scroll down through this file, you're going to get to the LCD section. Now this can be a little bit hard to decipher, but what we need are the RS pins and the D4, 5, and 6 pin values. So if you comb through these if and else statements, what we need are these pins right here. So back to our config, our RS pin, we have to take the comment off, that's going to be AR16. Our enable pin, take that comment off, that's going to be AR17. D4, that's going to be on AR23. D5, it's going to be AR25. D6, it's going to be AR27. And then D7 is AR29. And for this display, we shouldn't have to set up our check pin or our clock pin. But just take another look at Marlin right here. That's exactly what we just set up. Here's the D7 pin right here. And if we go down a little ways, the only other thing we really need to set up for the display is the encoder pin and the click pin. This is what lets you go left and right with your encoder wheel and the click button. So we'll uncomment encoder pin and click pin. And if you go back into Marlin and you come down to the section where it does rip rep discount smart controller, that's this 2004 display with the knob. Ignore the CR10 stock display. This is your button encoder left and right, 31 and 33. And this is your click encoder, 35. And both the encoder pins, left and right, need a pull-up resistor. So we'll do a caret, AR31, comma, and then a caret, AR33. And then the click pin, we need a pull-up resistor, but it also needs to be inverted. So we'll do the caret, exclamation point, AR35. And that should be it for the LCD screen. I did try to configure the kill pin, but it was doing some kind of crazy things, so I just left it off for now. So the last thing we need to talk about are G-code macros in Klipper. There's no G29 command in Klipper, and that's how we usually start our bed mesh leveling before every print. So like Duet, we would need to build a macro to enable that bed mesh leveling. And you can do that in Klipper right in this config file. So I'm just going to paste my snippet in here. Now the placement of these lines is very important. You need to put your G-code command over here, G-code colon, and then do a tab for each one of these lines that you add. So basically what this tells Klipper is you're going to have a G-code macro. Every time you enter a G29, you're going to run this G-code. So it's going to home G28, it's going to do a G1, it's going to jump Z up 10 millimeters, and then it's going to run the bed mesh calibrate command. That's going to do all the points on the bed, the 9 points that you usually see. And then after that G-code command is done, based on how you set up your start G-code, then your print should start printing. A lot of this might be confusing, but again, you can go use those example configs that Klipper offers, or you can use this config and take a look at it. Link in the description to all the stuff that I did today. So that's pretty much it. We can do Control X, hit Y, and hit Enter to save. Now we can run a command to stop the Klipper service, sudo service Klipper stop, and if we do a start, that'll start Klipper with our new config. Most of the time, if you're just making minor changes to the printer config, you can just do a sudo service Klipper restart, and that'll work the same. So let's pull up our Klipper Octoprint instance. We can go ahead and connect the temp printer again, and Octoprint will start running an M105 to check the temperature. If the temperature is 0, that's usually a really bad sign. If you enter any kind of command in, it's going to tell you what error it hit on the config file. So for instance, just do a G28. So we messed up something in the config, it doesn't know what probe is. So we've got something askew. So let's go back to the config, we'll stop Klipper, go back into the config, and we'll go down to where we set the probe. And I forgot to remove the comment off the probe line. So I didn't actually tell it that probe was active. So that should be all the fix that we need. Let's go ahead and save again, Control X, Y, and Enter. And then we can start Klipper back up, and we'll go back to Octoprint. We'll connect up again. Still something not quite right because the temperature doesn't register. Let's do a G28 again. So it doesn't like the min point. So let's go check the config again. Do a stop, printer config, go back down to probe. And it's the same error that I made before. I need to remove the comment off this bed mesh line. It thinks that this min point setting is in probe. Now with that comment off, it'll register correctly. So again, we'll exit, hit Y, hit Enter to save. We'll start up Klipper again, back to Octoprint, and we'll connect up. Still something not quite right. G28 doesn't like something about pin and bed mesh. Same issue. I need to remove this comment. So now we should be good. So we'll save, start up Klipper, connect. When you see Klipper state ready, that's a good sign, and now we see the temperatures correctly. So if you get an error while you're setting up Klipper that you can't get around, here's the sequence of events that you need to do to get off of that error. So the first thing I would do would be come in here and stop Klipper. Then you want to turn your printer off. You want to unplug the USB cable from the Raspberry Pi, turn your printer back on, plug your Raspberry Pi cable back in, and then start Klipper. That should get rid of any of the errors that you see that you might not be able to get around with just a stop and start. So now that the config looks good, we can come in here and do a test. Now you can't move motors until you home with Klipper, so let's just home the axis one at a time. So let's do G28 X. X home just fine. It did home just fine, but really slowly. I forgot to remove the comment from homing speed. So we'll do that. Nice thing about Klipper, you can just save this file and hit restart, and it'll pull your changes back in. So back to Octoprint, Let's do G28X again, much faster. Let's do G28Y and G28Z. So it looks good. Everything's moving in the right direction. Now if you needed to switch these around, you could flip the motor cable, or you can go in and use the exclamation point or remove the exclamation point from those pins. Now let's go ahead and heat up. The fan kicks on the minute you start that extruder heating up. We'll set the bed. And before we start a print, let's go ahead and test that G29 macro. So let's do G29. It should home, lift at 10 millimeters, and then run the mesh bed leveling. And the mesh bed leveling looks good. Now when it got done with the probing, you'll notice this information. So if you have a printer you don't want to run mesh bed leveling on every time you print, you can run this save_config command. It will put all these values in your printer.cfg file. You don't want to ever edit those values, but they will be there for every print until you run your next bed mesh leveling. I run G29 every time I print, so it really doesn't have any value to me. So it looks like everything's heating up correctly, everything's moving correctly. So let's slice a file. So there's a couple things I'm going to do differently from my start G code for Klipper, and one is I'm not going to run a G28. I'm just going to run the G29, because G28 is baked into that macro that we built in the config file, in that G code macro. So there's no need to run it twice. So G29 is fine, and if you run a prime line before every print like I do on the front of the bed, a lot of times those will do a lot of extrusion just to get that nozzle primed. Klipper doesn't like that so much. So I've actually lowered these extrusion values to 3 and 8. I had them set to 5 and 12, and that threw a Klipper error over extrusion. So bring those down a little bit if you use something like that. Everything else should be fine. I've got Slick 3R set up to export files directly to the Octopi that runs Klipper. So we'll send to printer, and we can go ahead and start the print after the upload's complete. The file is over in the Octoprint instance. It's heating up the hot end to 215, and the print will start momentarily. So we're up to temp. Our macro runs our G28 command. It brings Z up 10 and then starts the bed mesh leveling. We'll head to the corner to do our prime line, and the print starts just like we expect it to. And that's it. Now we've got Klipper set up and we're running our first print. A big thanks to Kevin O'Connor and all the work that he's done on Klipper. There's a lot of great stuff in there, and there's more being added all the time. Now I really can't tell you if Klipper is better than Marlin yet. It does have a lot of potential because of its ability to offload processing to that ARM processor. So we'll continue to test. I'm not going to lie to you, setting up Klipper wasn't easy. It took a lot of time and a lot of trial and error to go through all the different settings and make sure everything was correct. I hope you found this video helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.